Hello and welcome to a new episode of my Python Coding Challenge series. In last week's video, we used a formula developed by Euler in the 18th century to calculate pi. If you haven't watched that video yet, I've left a link to it for you in the top right-hand corner of your screen and in the video description. Today, however, we are going to take it one step further, and I will show you a geometric method for calculating pi. In particular, this has to do with the area of a circle inscribed in a square. If we assume that the radius of the circle is 1, then the area of the circle will be equal to pi, and the area of the square will be 2 squared equals 4. Consequently, if we take the ratio of the areas, we know that this will be equal to pi over 4. Now then, let's imagine generating a set of random points inside of the square. The ratio of the number of points that also fall inside of the circle, which we can call NC, divided by the total number of points generated inside the square, which we can call NS, will be approximately equal to the ratio of the areas. However, we know that the ratio of the areas is equal to pi over 4. So, by generating enough random points, counting how many fall inside the circle, and dividing by the total number of points generated, we should be able to approximate the value of pi. So that's exactly what we're going to do today. First of all, let's set up a counter for the number of points inside the circle. We can call this circ, and we can set an initial value of 0. Then we can set up a simple for loop where we calculate a random value for our x-coordinate and a second value for our y-coordinate of each point. We can do this by saying for I in range num points, and then we can say x equals np.random.rand times 2 minus 1, and the same thing for y. np.random.rand times 2 minus 1. And what this will do is it will give us an x and y value that is between -1 and +1, with a circle having a center in the origin, so at 0, 0. Now, to calculate whether or not the point is inside the circle, we have to determine its distance from the center. If this is smaller or equal to the radius of our circle, which we know is 1, then the point is inside the circle. Else, it is outside of the circle. So we can say that the distance, which we can call dist, is equal to numpy dot square root of x squared plus y squared. And then we can say if dist is smaller or equal to 1, then circ plus equals 1, because we know that our point will be inside of the circle, and therefore we can increment our counter by 1 unit. Now we can finally approximate the value of pi by using the formula we saw earlier. That is to say, pi equals 4 times circ, so the number of points that were inside of our circle, divided by the total number of points generated, which is given by the value num points. Then, as we did last time, we can print our value of pi and also print the value of pi contained inside the NumPy library as a comparison. Let's now run our code by pressing the F5 key, and then we can call our function on the right-hand side by saying calc pi2 for a value of, say, 10 million points. As you can see, we were able to roughly estimate the value of pi, which is impressive considering that all we did was generate some random points and then count how many were inside of the circle. Having said that, I hope you enjoyed this geometrical solution to finding the value of pi. Don't forget to check in next week for the final solution, in which we will use a state-of-the-art algorithm to easily calculate many digits of pi. In the meantime, don't forget to check out my previous coding challenges and Python tutorial videos. I'll leave a link to both of these in the top right-hand corner of your screen and in the video description. Also, don't forget to leave a like, share this video, and subscribe to the channel for more fun coding activities. As always, I look forward to seeing you next week, and until then, happy coding!